In the mountains above Denver, engineers are stacking a new dam on top of an old one. And if they get it wrong, the city could lose one of its most critical water supplies. High in Colorado's Rocky Mountains, hidden behind forested ridgelines and snow-covered peaks, sits a reservoir that has quietly supplied water to Denver for more than 70 years. Gross Reservoir was never meant to be famous, but today it has become the center of one of the most unusual and controversial water projects in modern American history. Faced with rising demand and extreme climate swings, engineers proposed something almost unheard of. Instead of building a new dam, they would build on top of the old one. And in doing so, they would attempt the first transformation of a gravity dam into an arch dam anywhere in the world. Please take a moment to subscribe and like the video. It really helps the channel. Denver Water now serves around 1.5 million people every day, a number that has grown by more than 100,000 since 2016. But population growth is only part of the problem. Climate volatility has reshaped the region's water reality. In 2002, Colorado suffered a historic mega-drought. That same year, the Hayman Fire burned through more than 100 homes and permanently altered entire watersheds.
This was a fast-moving giant of a fire.
Rifts have never seen a fire burn this hot, this fast.
Since then, floods, wildfires, and heat waves have grown more frequent, placing unprecedented strain on water systems built for a more stable climate. The imbalance is structural. Nearly 90% of Denver's stored water sits south of the city, while only 10% lies to the north. Gross Reservoir sits on that northern edge, making it strategically critical, but its capacity no longer matches the risk profile Denver now faces. When Gross Dam was first built in the 1950s, its designers were already thinking ahead. The structure was intentionally engineered to allow future expansion, a rare foresight in mid-century infrastructure. The reservoir is fed by the Fraser River and connected to the Colorado River system through the Moffett Tunnel, a key trans-mountain diversion. The dam itself was named after Dwight D. Gross, Denver Water's former chief engineer, whose team understood that water demand would one day outgrow the original design. That day has arrived. Originally, Gross Reservoir could hold 42,000 acre-feet of water, roughly 52 million cubic meters. In 2020, federal approval cleared the way to nearly triple that capacity. Once complete, the expanded reservoir is designed to store 119,000 acre-feet, or around 150 million cubic meters of water. That additional supply could serve approximately 72,000 homes every year. To make that possible, engineers would raise the dam by 131 feet, taking it from 340 feet tall to a total height of 471 feet. That scale of vertical expansion is almost unheard of for an existing dam, especially at this elevation. Construction began in 2022 at an elevation exceeding 7,000 feet above sea level. At that altitude, weather windows are short, oxygen levels are lower, and logistics become significantly more complex. Engineers designed the raise as a series of 118 stepped concrete lifts. Each step rises 4 feet and sets back 2 feet, slowly transforming the dam's profile from a traditional gravity structure into a curved arch that pushes water pressure into the canyon walls. At the crest, new infrastructure takes shape. Control buildings, electronic systems, railings, and a spillway bridge are all integrated directly into the structure. By June of 2025, construction reached the height of the original dam, marking a symbolic midpoint where old and new engineering finally met. The original dam was built using conventional concrete, poured in massive 50-foot blocks similar to those used at Hoover Dam. That approach worked in the mid-20th century, but it would be too slow and too carbon-intensive for this project. Instead, engineers turned to roller-compacted concrete, or RCC. The process looks more like road construction than traditional dam building. Dump trucks deliver the material. Bulldozers spread it into thin layers. Smooth drum rollers compact it into a dense, load-bearing mass. This method allows concrete to cure at lower temperatures, reduces cracking, and dramatically speeds up construction. The scale is immense. The original dam contains around 600,000 cubic yards of concrete. The raise adds more than 700,000 cubic yards of RCC. This makes Gross Dam the largest dam raise ever attempted using roller-compacted concrete anywhere in the world. When approved in 2021, the project carried a price tag of $531 million. Denver Water structured the funding to avoid taxpayer dollars. The entire cost would be covered by ratepayers, new connection fees, and revenue from renewable energy sales. A hydropower plant operating on site since 2007 already feeds electricity back into the grid, offsetting part of the project's cost. But as construction advanced, legal challenges and new permitting requirements began to threaten that budget. Delays at this scale do not come cheaply, especially when heavy equipment and labor crews are already mobilized at high altitude. In April 2025, everything stopped. A federal court issued an injunction halting construction entirely. The lawsuit was brought by a coalition that included the Waterkeeper Alliance, the Sierra Club, and Save the Colorado. The judge ruled that the environmental review process was incomplete. Specifically, the U.S. Army Corps of Engineers had failed to fully assess impacts across the entire Colorado River Basin or properly evaluate alternative solutions. For a small environmental coalition, it was a major legal victory. For the project, it was a sudden and costly standstill. Just 1 month later, the ruling was reversed. The judge determined that leaving the dam unfinished posed its own flood risks, making continued construction the safer option. Work resumed almost immediately, but a critical restriction remained in place. Denver Water was not granted permission to fill the reservoir, even if all approvals are eventually secured. Filling the expanded reservoir would take around 5 years. New permits are still required, and the timeline remains uncertain. The structure may be completed long before it is ever allowed to function as designed. Denver Water argues that the project delivers net environmental benefits. Mitigation plans include increased creek releases to improve fish habitats, the creation of new wetlands, and long-term land preservation programs. But the environmental cost is undeniable. Nearly 200,000 trees have been removed, and construction runs around the clock. Opponents counter that the Colorado River's flow has already dropped by roughly 20%, and that adding another major reservoir only worsens basin-wide shortages. This is now the largest construction project in Boulder County's history, affecting more than 1,000 nearby homes through constant noise, traffic, and disruption. Construction is scheduled to wrap up in 2026, with spillways and support buildings finalized. If approvals are granted, reservoir filling could begin in 2027. But there is a real risk that the dam could stand complete, raised to its full height, yet never filled. The Gross Reservoir expansion is one of the most ambitious dam retrofits ever attempted in the United States. It is technically groundbreaking, legally complex, and environmentally divisive. This project is defined as much by resistance as by innovation, and it leaves behind a question that extends far beyond Colorado's mountains. Is this the future of water security in a changing climate, or a warning sign of how far infrastructure can be pushed before nature pushes back? Thanks for watching Unthinkable Build. We'll see you in the next one.